In this video, I'm going to solve two problems, 15 and 16 on the assignments of week 3. The first one is problem 15. The plus counts of a group of women have a bell-shaped distribution with a mean of 256 to 59.7 and a standard deviation of 62.7. Now, using the empirical rule, we are asked to find part A and B. Okay, so go back to the empirical rule from section 3.2. We know that we are given the bell shape, right? The bell shape like this one, the bell curve. Now, the center is the mean. This is the mean, right? And according to this rule, we have 68% of the data would be within one standard deviation. So that means from the mean, if you add one more standard deviation, or if you subtract one more standard deviations, then this is one standard deviation above and below the mean, then there would be 68%. So 68% of the data would be between one standard deviation above the mean and one standard deviation below the mean. Now, if you add one more standard deviation, so we take the mean, we add two standard deviation. That means from here, we jump one standard deviation, two standard deviation, and now from here, we jump backward, one standard deviation, and then one more. So the mean subtract two standard deviation. So we have the second one around this area. There would be 95%. So 95% is inside two standard deviations. So within one standard deviation, there are 68% of the data. Within two standard deviations, we have 95% of the data that you could see them here. And then for one more standard deviation, 3 standard deviation, then you would have 99.7%. So within 3 standard deviations from the mean, below or after the mean, there would be 99.7% that all the data that you can find them inside 3 standard deviations above or below the mean. So in this case, part A, they ask you what is the approximate percentage of women with the plus counts within 2 standard deviations of the mean. So 2 standard deviations of the mean, we know that they are 95%. So according to the rule, part A, the answer is 95%. Right? Inside 2 standard deviations above and below the mean, we have 95%. 1 standard deviation, we have 68%, and 3 standard deviation, we would have 99.7%. And we can see this rule or the figure on page 104 of the textbook. Okay, so that is the answer for part A, 95%. And part B, what is the approximate percentage of women with the plus counts between this point and this point? Okay, so we are given 2 values. This is the data point 197.0 and 322.4. Now, in order to see if this point is inside which region here, we would have to convert it back to the same unit that we have here. So you take the data point, subtract the mean value. We are given the mean. So we take the data point, we subtract the mean, and then divide by the standard deviation because we want to convert them back to the z-score value. Okay, so doing that, 197 minus 259.7 divided by 62.7, we would have -1. And then the same thing here, we have the data point, we subtract the mean value, and then we divide by the standard deviation, 62.7. And that would give me +1. Okay, so we know that the z-scores for these two values is going from -1 and 1. That means we have the location for these 2 points are one standard -1. That means one standard deviation below the mean, and +1 means one standard deviation above the mean, which is this value and this value. So we have one standard. So this telling me that this is within one standard deviation below or above the mean, and that would be 68%, because one standard deviation above or below the mean, according to the rule, according to this empirical rule, then there is 68%. So the answer is 68%. Now, problem 16. According to the data, again, the blood counts of women, we have the bell shapes, right? The bell shape. This is the bell shape. Now, we have the mean. So we have the mean to be 255.1, and the standard deviation also given here. Now, using the Chebyshev theorem, what is known about the percentage of women with the blood counts? That are 2 standard deviations of the mean. Okay, so you are looking for the percentage of the women that are 2 standard deviations above or below the mean. Okay, now, so we have this special theorem. Chebyshev theorem, and this theorem is telling you that we have at least 1 minus 1 over k squared. We have at least these percentages that should be within the number of the standard deviations of the mean, and k here, the k value here is the number of the standard deviation of the mean. In this case, we are looking for 2 standard deviations of the mean. That means k is equal to 2. So 1 minus 1 over 2 squared. And that would give me 1 minus 1 over 4. And that would be 0.75. And if you are converting it back to percentage, you are moving 2 places to the right, and that would be 75%. So we have at least 75% of the women that have the blood counts that are within 2 standard deviations of the mean. Now, to find the mean and the max value within 2 standard deviations of the mean, it's very simple, right? So we have the mean value and we have the max value. Okay. Now we know that the mean was given 255.1. Okay, because so we know that this is the mean. For example, here the mean is here. Now we have two standard deviations. So in order for you to get to the mean value, we go to the left side, two standard deviations. That means from the mean, we subtract 2 times because this is two standard deviations of the mean. So we subtract 2 times. And we multiply with the standard deviation 65.4 to get you the mean value. But to get you the max value, we go to the right 2 times, right? So the same mean value, but we add them, 2 standard deviation, and we multiply with the given standard deviation s here. So 65.4. So 255.1 minus 2 times 65.4, that would give me 124.3, and this is the mean value of that data point. And then if you add that to 55.1 add to 2 times 65.4, that would give me 385.9, and this is the max value. So this is the mean, the middle value, okay? Because we have two standard deviation, that means we go 2 times above to get the max value, and then 2 times below the mean to get the mean value. And then each of the units, the increment or decrement, is the value of the standard deviation, the s value. So you subtract 2 times that, or plus 2 times with s. So that's how I solve problem 15 and 16 of the week 3 homework assignments for section 3.2.